So once you have a function, if I tell you something is a function, notice all of these are in function notation form. Functions that are symmetric about the y-axis are even. And remember, to test for the y-axis, what do you change? What letter do you change?
X.
Right. So look, write this. When I plug in negative x and I get the original, it's even. When you end up with exactly what you started out with. If it is symmetric about the origin, we're going to say it's odd. And guys, what did we change on the origin? Both of them, that's right. So I know that if I plug in an odd x value, an opposite x value, it's going to be the opposite signs. It's going to be the opposite of the original function. Look where my negative is. You have to memorize this. When I plug in a negative x and I end up with what I started, it's even. If I plug in a negative x and I get all the opposite signs, it's odd. Let me show you what I'm talking about. For number 9 through number 12, we don't have to worry about the x-axis. We know these are functions. We are only using what is in this box right here. So let's go ahead and test the y-axis. Am I on the screen? Let's go ahead and test number 9. So we are only plugging in the opposite, and it's going to tell us what's going on. So we're going to have an opposite x, and let's see what happens. So it is going to be negative x, remember parentheses are your friend, minus 2 times the negative x. Yo, what's a negative times a negative times a negative? What kind of sign is that? It's a negative. So to clean this first term up, it's going to be negative x to the third. Look at this next term. What's a negative times a negative? Positive. We're going to write plus 2x. Does this match what we started with? No. Is it completely opposite? Are the signs opposite? This was positive. Is it negative now? Yeah. This was negative. Is it positive now? Yes. If all signs are opposite, what else starts with the letter O? The origin. Then it is symmetrical about the origin. So you have the word origin, starts with an O. You have the word opposite, starts with an O. What else starts with O? Odd. It is symmetrical about the origin. If all of your signs are opposite, you're going to say it's an odd function. So this is odd. Remember, you are only plugging in negative x. Hey, I'm going to do a homework problem with you. You want me to do one of your homework problems? Let me do one of your homework problems. Let's look at problem 14.
Which one?
No, it's on page 14. Let's do problem 34 together on page 14.
Let's do it.
Page 14, number 34. Am I on the screen? All right, so we have this is the original.
This is due tomorrow.
Totally. We're going to plug in negative x. Parentheses. I love parentheses. They're like my best friend. All right, here we go. What's a negative times a negative? Right. So this turns into positive x squared. What is that? What's a negative times a positive? Right, negative 6x. That is correct. Oh, well, there's nothing on the 10, so just write plus 10. Let's analyze what just happened. Are these the same? Those are the same. Are these the same? Oh, then it's not even.
So it's odd.
Well, remember, it's only odd if all of their signs changed. Those did not change, guys. These changed. Did the 10 change? No. So if it is not completely opposite, not completely opposite, then it is not odd. Then that means it's neither. That's